But it's that sort of thing that you look at, and I designed coatings as I went through all these things that would fix problems. And that was the key, because if I don't have something that'll fix your problem, I'll tell you. But about anymore, after all these many years, about 80–85% of those problems we got an answer for. We just need to see it first and understand it, and then I think we can fix it this way because we've done it before. And we made this coating to do that. And so that's important. I am Joseph Pritchett, or J.E. as I go by the name. And I'm industrial specialist on coatings. And the reason for that is that, kind of a funny beginning, but I was out in the field and I walked the oil fields in Colombia, jungles, and down in Mexico and different places where it's hot, a lot of corrosion along the Gulf Coast and just coastal areas, and trying to sell Supertherm for insulation and all this. And I was told early on, we don't really care about your old insulation coating. If you can't fix my corrosion problem over there, then get out. And I thought, well, that's kind of direct. But I thought, okay, fine. That's, well, you're using everybody from all the major players. I said, so what's the deal? And they said, well, we come in, they blast, and then they coat their 3-coat system, and in 3 to 6 months, got bubbles on it. You take your knife, you pick the bubbles, got corrosion. Why is that? And I thought, well, why is that? You know, and I thought, okay, let me kind of study this a little bit. So I then started asking questions about what's going on here. I mean, you do a blast, right? Yeah, well, doesn't that clean it up? Absolutely. It's a white blast. Okay. And I said, then you paint it. Yeah. Well, when's the painter there? Oh, he comes within a day or two. Excuse me? You do a white blast on a coastline, you don't start painting it immediately, you're going to have a bloomed out or flash rust on it within a day or two. So by the time, what they were doing was putting on zinc-rich primers. Well, what is a zinc-rich primer? I had to learn all this. And so it's like, what's a zinc-rich primer? Well, it's a self-sacrificing material. What do you mean by that? Well, you put that on, and then when corrosion comes through your top coat or something and finally hits it, it will corrode and give itself up before it lets the metal behind it corrode. I thought, that's strange. But that's the system. Yep, that's the system. Okay, and then, so what is the system? Well, you do a white sandblast, then you have the zinc, then you have an epoxy, and then a top coat urethane. I said, why is the epoxy there? Because the urethane and the zinc-rich primer don't get along and they'll bubble each other, gas each other. So you have to have an epoxy just to separate them. Okay. And I thought, but you get all this done and it bubbles. It starts corroding within 3 to 6 months. Yep. All right. And I said, well, this just sounds odd. And I said, but wait a minute. So your painter doesn't set up and get stuff, even if he's there on site somewhere, he's got to wait until all the blasters get all their stuff out of there, and so he can get his stuff in. Well, that might be the next day. You've already got some blooming going on or some flashing rust. So he sets up. I'm following the checklist. Blast, primer coat, medium coat, top coat. So they blasted. I come in there and I put the zinc in later on, or the primer, whatever it might be. But I'm going to put the primer in. Didn't say in there somewhere you had to be immediate. It just said put it on. Okay, so he's following the routine. So he comes in there and starts spraying it on. It's already kind of bloomed out a little bit. Well, the zinc is self-sacrificing, so when it goes onto that corroding surface, it starts to corrode itself. So in about, within about, well, they said about 3 to 6, let's just say 6 months to a year, You've got some bubbling. It's got corrosion underneath it. Some of it's maybe delaminating. Why is it delaminating? Because the primer started corroding and lost its adhesion to the metal because of the corrosion that developed. And I thought, well, okay. And I said, well, what if you got it on there immediately? Well, now that would be good. That'd be better. Okay, but did that work? Not 100%. And I'm going, well, it lasted longer, but not 100%. And I thought, well, what's going on here? And then I got to, as I started talking to the engineers and metal people with the steels and things like this, and then they started saying, well, you know, down in the pores of the metal, it's still active. Even with a blast, corrosion's still active down in the pores. And you put your primer on, middle coat, top coat, all looks fantastic. But that activity was still going on in those pores, and it didn't stop. And so it just kind of kept on going, and then finally it started gassing off while it's corroding. It gasses off, and there's your bubble. And then it's corrosion all the way down into it. And I said, well, obviously you got to stop the corrosion down in the pores then if you want to get control of this. Yep. Well, I'm not that brilliant, so why didn't somebody come up with this already? I'm trying to sell Supertherm, you know, and now you're forcing me to come up with a corrosion coating here. But okay, all right. So it's like, okay. So I started thinking about that. I said, what does that? What gets into that? So I got to talking to other people that's involved in corrosion and everything. And then I'm talking about resins, because I've already learned you better have the right resins for this to all work out. Well, in corrosion, what's your resin? It's got to be tough. It's got to lock on. It's got to do all this kind of stuff. So I finally, along the way, I found out that all the coatings, normally, top coats, all this kind of, they're a coating that glues to a surface. Okay, well, normally I guess that's all right. But they glue to it. They don't get down in it. They just glue to it. And that's supposed to take care of everything. Well, it doesn't. So I said, well, what gets down into it? Well, then I ran across a company that I started working with, and I took their technology and changed it some with their approval, and developed out something we call Rust Grip. Rust Grip is a polyurethane, a moisture cure. Now everybody ran from moisture cure urethanes because we don't know how to use it, and we throw it out there. Well, they don't know how to use it. That was the problem. They threw it on something that's damp. Coastline, it's usually damp or something, but you can get it dry, you know, and do it right, and it'll work. And if you need a little acetone or something like that to dry it out even more before you coat, you do that. But none of them are doing it. So I developed this formula that was a moisture cure, but it had ingredient in it that would slow down that reaction to moisture. That was a key. Then we had a low viscosity, so it would penetrate and get down into those pores. And once it got down into this pore right here, if you get down into it, it gets down, pulls the moisture out of there. It's a moisture cure. What does that mean? It means it starts to take the humidity out of the air and it starts to gas itself. Is that good? Yeah, because then here's this pore and the cavity of the pore. It swells and fills up the cavity of that pore. It can't breathe anymore. Then it fills up and seals the outside to 6,780 psi or 470 bar. That's tough. Now, can it flex? Yeah. Does it have any elongation? No. But can it flex? Yeah. We put it on train cars and things like this. And they're running down the road doing this. So it'll hang with that. But then you have now smothered out the point of origin of the corrosion. down in the pores. And that's key to corrosion control. I put it on top of when I couldn't blast in Panama Canal and ships coming through. I was able to get on there and you don't have time to blast, and they wanted you to do something in a hurry. Well, I didn't paint anything with rust grip. I slathered it. What does that mean? That means you practically pour it on there and just use a brush and work it in and just get this corroded thing coated. And it was encapsulated, meaning that it got down into the pores, got down into the cracks, got into the existing rust that was there, locked in. It couldn't. Now it's got a permeability of 0.24. That means anything below 1 is can't breathe. So now it can't breathe, it can't get moisture, it can't do anything, and now we've locked it up. And that's where rust grip comes in. And it's tough, it strengthens surfaces, concrete, things like this. Put it on, it takes that concrete to 6,700 PSI, or 470 bar, on docks and all kinds of things. Now, rust grip is made with resin, moisture-cured polyurethane resin that is designed to penetrate down in there, then draw the moisture, swell and lock and encapsulate the surface. Then we have aluminum in there that then is non-leafing, so it lays down so that it provides, along with that very tough resin, it puts in a layer that's going to be extremely tough, because we've got it out on oil rigs and things. They drop tools on it, and it's tough to tear up. It's tough to dig into it. We even had down in Pemex oil, Mexico, we didn't know they were going to do this, but they said, so you've coated this metal plate right here, and we'd only put like 4 mils or 100 microns on this metal plate, just to show what it looked like. We weren't trying to go up against some kind of a major test. And they said, so that's the metal plate and that's what it looks like? Yeah. And they said, okay. It was about a 1/4 inch steel plate, and we just coated it so everybody could see it, see how it locked in, get the, do pull test on it, all this kind of stuff. And they said, okay. So they brought a tractor over with a winch on the boom, and I'm looking at it like, what are you doing? And they had this about a 3.5 meter, 4 to 5 foot I-beam, and they had a rope around the top of it, picked it up, and then they cut this thing into a point. And I'm going, what are you doing? And they said, well, you said that it ties into the pores and it won't knock off. It's locked into the surface of the metal. And I said, yeah. And then they go, we're going to test it and find out. And I thought, what are you going to do? We're going to raise this thing about, 6 meters in the air and about 20 feet, 18, 20 feet. And then we're just going to pull the rope and let it drop down, and that point's going to come down and hit that thing. He said, we've never had a coating yet that didn't pop off. And I'm sitting there going, okay, you better tighten up your belt here. We're going to find out. I thought, I've never done, this is no ASTM test, that's for sure. And I said, okay, do it. So they raised it up and dropped that thing. It came down and hit that. Well, the nose of that thing, that must have weighed 200 kilos. And, so 400 something pound on that thing. And it dropped 6 meters, or about 20 feet, came down and hit that thing, and bam! And so everybody then went over there and looked at it, and moved it around and looked at it and says, nothing came off. Where it went through the coating, of course, on the point into the metal, it wasn't there because it smashed the coating right out of there. But the rest of it was still coated and locked in. So the director was one of them. I didn't know he was a director, but he was there watching it. He said, okay, all right. I believe you. I said, so that's not ASTM or ISO testing, is that right? And he laughed. No, that's our testing. You know, you come out here, you say what you're going to say, then we're going to test it and see. So they did another test the next day with just this metal big plate that they used with the same thing and dropped it where it would come down on top of this other thing we had coated, and it did the same thing. And it didn't have a point in it. It just hit it really hard, and it didn't do anything. And then they said, okay, well, how is this with torch? And if you're welding or you're cutting? And I said, well, it doesn't burn. It doesn't want to burn. It has about a 5 on a scale of 25. It has about a 5 on a burn if you burn it, and it flame spread. And he says, okay. So they had about a 1/2 inch steel out there coated with rust grip, and they got a acetylene torch, a redbud. And I thought, I don't know what you're doing now. He said, but he got a piece of metal and angle iron, put it up there, and then he just started cut this thing down through there and cut it all the way down, and then took it and then moved that back and took his glove and wiped it, and he said, okay, it didn't burn back from where we cut it. Pretty good. Again, okay, we believe what you say. I said, where's this an ASTM test? But it won't burn. And so if somebody's welding, will it burn back? No. Where you welded it, it burns that, and it's got there. So if you go back, you can just recoat the weld, and you got it. We did that on a casino boat that they were building over in Michigan City, Indiana, around Chicago area, Great Lakes, at the bottom of the Great Lake right there. And they were building this big boat. And so I was over there, and I told them, I said, well, actually, it would be better if the metal was kind of bloomed out a little bit, and you got it all welded together, and I want it to have a little bit of just surface rust on it. And nobody had ever heard of that. The engineering staff for both the boat, the steel company, and the Coast Guard was there, and they're going, you're full of it. You know, you have to have a white sandblast before you coat anything. I said, not with this coating. It's an encapsulation type coating. But they didn't know what that was. It didn't go in, swell up, lock in, seal it off where it can't breathe air or moisture. Encapsulation. They never heard of that. So I said, that's what it does. And so we had a big argument. But the product's already sitting there. We're going to apply it. So we're going to get on. And they said, how do you know that this is after about 3 or 4 hours of just griping, groaning, and moaning about it all. And so finally we're out there by the boat, and one of them said, how do you know it's the rust is about right? So being a smartass, I just took a screwdriver and scraped it and said, yeah, it looks good. You know, and they looked at me like, and then so we started spraying, and they found out by the next day it's locking on, it's locking in, it's encapsulating, it's 6,700 PSI, 470 bar, tough. And they go, whoa. And the only reason why I sold it in the first place is that the owner, Boyd Gaming out of Vegas, had said, I can save $1.5 million by not blasting the metal before I coat it, if I use this coating. And I said, yes, it'll work. Well, they believe me. Well, if you deal with those guys, you better be right. They may visit you. So, but we put that on there. Then we came back, and they said, okay, they had already found out that on an earlier boat that was sitting there, that the standard insulation they had put on the inside for insulation to help hold heat in the boat during the wintertime and heat out during the summertime. And it gets very hot during the summer, very cold, and snow during the wintertime. And I said, is that working? And they said, well, yeah, it's the standard. It's what we've always used. And I said, and he says, you say. Now, we've got about 4 to 6 inches inside this thing. But you're telling us that this supertherm at 10 mils, 250 micron, is going to do the same thing as that 4 to 6 inches, 150 millimeter or 100 millimeter of the standard insulation. Yeah. Why is that? Because that loads heat and I don't. Period. That's it. Well, they didn't understand that. Oh, we don't believe that. I said, well, it works that way. And I went through it all, and I showed you the testing that we'd already done, and it works. So there was this big argument and everything. Well, then finally, when I won the argument that we were going to apply the supertherm, then one of the engineers said, well, you know, that stuff never worked anyway, the standard stuff, because it loaded the heat like it was designed to do. Then when that heat source got over to that cold, during the wintertime, that cold hull of that boat, that warm, moist air cooled down, and it dropped its moisture out, and it was just like raining. Water was running down on the inside of the hull, and we had to have pumps pumping it out. And I looked at him like, we went through 4 hours of argument, and you never said this. You're just going to see if I'm still standing at the end of the 4 hours, I guess. Okay, yeah. And I said, so it never really worked? No. I said, okay. So then we had coated the inside and the outside of the hull. And this was in November, about that time. It's starting to get cold, things like this. And so then I get a call, and in Kansas City. And so I say, yeah. And they said, well, this is the boat, the engineers at the boat. And you better get your butt over here, because we got condensation running all over the inside of this boat. And you said it wouldn't happen. And we're putting in that carpet that you put in inside the casino. It's expensive. These wall things in here, it's expensive. And if it ruins it all, we're going to hold you liable for it. And I thought, whoa, okay. So I got on the first plane, went over, rented a car in Chicago, and drove around to the boat. So they had all of the engineers there from their different groups, and from Boyd Gaming, and some representatives there. And they were already inside the trailer home, the mobile home that they were using for an office. And I thought, I got to go out and see what's going on in this boat. So I grabbed a hat, hard hat, glasses put on, went out there in the boat, and I'm asking them, I say, but before I got there, I said, look, so it's condensating? Yeah. I said, I want you to go down to Walmart. I want to get these big fans. I want you to turn them on, and I want that air circulating before I get there. And that'll stop the condensation. And they never heard that. And he says, how do you know that'll work? And I said, if air is moving, you won't have condensation, because it's moving past it instead of letting the warm, moist air just set on that surface and cool down and condensate, now it's blowing past it at a speed that it can't sit there and condensate. And it'll keep it from doing that. So anyway, so they had done it. So when I got there, I went in there and I was looking around and I was asking, well, is it condensating? No, not since we turned the fans on, but before we did. Oh man, water's everywhere. And now I'm standing there at a loss. What's going on? Now, do I get in a car and drive to the Mexican border? Or do I come up with some kind of an answer? Because I'm at a loss as to what's going on. You know, it shouldn't be doing that. And about that time, this is where you have a little something sitting on your shoulder right here watching out for you. About that time, here comes a guy to replace one of the propane tanks that they're using for heaters inside. And I just looked at him and I said, yeah, I'm at a loss here. I said, does those things put off any kind of moisture during the burn? He goes, well, hell yes, they do. And I thought, well, how much? And he says, well, the amount of heaters we got in just this level right here, about 400 pounds of water every 8 hours. Oh, I nearly kissed the guy, you know, because I thought, it puts that much water out? Yeah, with the heat. And when you burn propane, it puts out moisture. I thought, whoa, okay. So then I went into the meeting. When I got in the door, one of the guys who had promoted that we be doing what I was doing said, oh, you're in trouble. You're in serious trouble. They've already had a meeting of how they're going to lynch you and cut you up and spit you out. And I said, we're okay. And he just looked at me like I was crazy, been drinking or something. And I said, no, we're fine, we're fine. And he says, okay, well, they're starting it back up in about 5 minutes and they're ready for you. I said, okay. So anyway, I walked into the room and sat down, and here they all came back. Sit down, and so this one engineer that was always against the whole idea anyway, he stands up and he starts telling me, you know, I told you in the beginning this wasn't any good and it wouldn't work, and and man, he just started in. He's like a Gatling gun, you know. And so I listened to him for a while, and finally, he's starting to thinking he got it going, and I stood up. I said, you've said enough. And I said it that way with that look, you know, and everybody went, what? What'd you stand up and say that for in the middle of getting cut up? And I said, why don't you sit down and I'll explain something to you. You know, now I'm the expert, and they don't know that I just learned to be the expert, but I'm the expert now on this water thing. So I explained how supertherm works as if, you know, it's, you know, the emissivity, throwing it back off the surface and keeping it in the room and all this kind of stuff so it doesn't load into the metal and be lost to the outside where it's cold. I went through all that. And I said, you understand that? Yeah, but that doesn't have anything to do with it. It's still condensating. He says, stop right there. Do you know how many heaters you're using out there? Now, see, I just learned this, but they don't know it. You know how many heaters you're using out there in that work site? Well, no. I said, well, you got about 8. I said, you do know that you know, that puts off about each heater puts off about 100 pounds of water, of moisture, or 50 pounds of moisture every 8 hours. Now, everybody knows that. You know, and all these guys, none of them knew it. I was a little shocked, but none of them knew it. And I went, and they're looking at me like, what? And I said, yeah. I mean, everybody knows that if you're going to use heaters, that those propanes put out about that much every 8 hours. You have 400 pounds of water hitting that wall all the time, all during the day, every 8 hours. And so anyway, that they just went, whoa. And so the owners that was there, the representatives went, and so they looked at the one engineer that stood up, and he says, you got any more questions for this guy? And he goes, no, I don't think so. He says, how much of that do you believe? He said, oh, at least 90%. He said, this meeting's over with. Thank you very much. So you run into these situations, and you got to explain them. And that's like in the same boat later on. They had one room that wasn't holding the heat like I said it would. Everything else was doing it. Then when we got a hold of them and we said, well, let's go to the room and check. And then when we got in there, one of the labor guys said, well, we hadn't put HVAC, the ducting, in this room yet, so it's not getting any heat. So how could it hold heat if it's not getting any heat? And it's like, and so I came back and told him, I said, if you'd put ductwork in there to get heat in, we'll hold it. But until you put ductwork in, it ain't going to hold any heat because there's no heat. And so you have to, you know, just look at what we try to do with the coatings is we're just simply there to fix problems. And that's what we say. It says, I'm not selling you a coating until I hear what the problem is. What are you trying to do? And that's extremely important. Don't go in there selling something until you know what the problem is, and then it's like, can you fix it or not? Now you got to make that decision, Because if you can't fix it, you need to tell them. But if you can fix it using something else and your coatings to maybe make this lock in, then go for it. But your coating may not do the whole thing, but listen to the problem. Understand what the problem is. Okay, now why am I that way? Because I walked the fields, the industrial fields, the heavy industrial fields, the oil fields, and all of this. In the early days, just learning, that doesn't work. Well, why not? Well, that doesn't work. Well, why not? And then if I had something that would penetrate and do this and that would work, then how about an insulation? That work? And you can't wrap things because, and I was always out there when they always took the metal jacketing off of all this piping through a plant. All that stuff is just hanging because it got wet. It's not doing anything. And the pipe is all corroded. And I said, well, if we coat that, it's coated and sealed. It's not going to corrode, and it's going to work from day 1 to day 6,000, instead of loading up with moisture and hanging off and not doing anything. And but it's that sort of thing that you look at, and I designed coatings as I went through all these things that would fix problems. And that was the key, because if I don't have something that'll fix your problem, I'll tell you. But about anymore, after all these many years, about 80–85% of those problems we got an answer for. We just need to see it first and understand it, and then I think we can fix it this way because we've done it before. And we made this coating to do that. And so that's important.